Lying quietly in the frozen darkness of the solar system, where sunlight reaches only as a faint whisper, Pluto emerges as a mystery that refuses to fade. Discovered in 1930, it was once celebrated as the 9th planet, only to be demoted to a dwarf planet in 2006, a decision that still stirs debate. The journey to understand Pluto is more than a scientific endeavour. It is an attempt to define its place in the universe. With its eccentric orbit, its icy surface full of surprises, and the haunting possibility that it may hide life beneath its crust, this small world feels at once familiar and profoundly alien. Tonight, we'll gently place our ear against that frozen world, listening for what might stir in its depths. Perhaps it's nothing but billions of years of silence, or perhaps, in the coldest shadow, there flickers a secret flame of life never seen before. And welcome back to the Sleepy Explorer, a gentle place where the universe becomes a bedtime story and awe arrives unhurried. Don't worry, this isn't the kind of space talk that will keep you staring at the ceiling. Think of it instead as opening a storybook at the edge of sleep, where fact and myth wander side by side, and every mystery feels like a gentle dream. Before we begin, I'd love to know, where are you listening from tonight? Are you wrapped in a blanket, with the glow of your screen the only light in the room? Or maybe outside, where the night air carries the sound of crickets? Share your local time too, if you'd like. It's always magical to see this sleepy little community scattered across the earth like constellations, all under the same sky. And if this quiet voyage brings you a moment of calm, you're welcome to give it a like or subscribe only if it feels right for you. That way, this little ship of wonder can keep drifting outward, finding new companions in the digital night. So let us turn the page and begin tonight's story. Is Pluto hiding an underground world of life? At the very edge of the solar system, nearly 40 times farther from the sun than Earth, there drifts a world so small it could be mistaken for a moon, and yet so haunting that it has held human imagination captive for nearly a century. This is Pluto, a sphere of rock and ice, locked in a darkness where sunlight feels like little more than a memory. Out here, the sun shines no brighter than a pale lantern, barely strong enough to cast a faint glow across Pluto's surface. Shadows stretch endlessly, and the air is thin, fragile, and cold beyond comprehension. And yet, in this stillness, Pluto bears a mark that feels almost alive. On its surface lies a dazzling white plane, carved in the unmistakable shape of a heart. Scientists call it Sputnik Planitia. It stretches over 1,000 kilometers across, large enough to cover nearly 1/6 of Pluto's diameter, and gleams like a scar against the darker crust. When the New Horizons spacecraft flew past in 2015 and sent home the first close-up images, the sight of that heart stunned the world. Here, in a place long imagined as nothing more than a frozen rock, was a feature that seemed to speak directly to us. But Sputnik Planitia is more than a poetic symbol. To scientists, it is a clue. Its very existence raises questions about Pluto's interior, about how a world so distant and so small could remain geologically active. Beneath the nitrogen ice of the plain, many believe there may be an ocean, not an ocean under an open sky, but a dark sea buried hundreds of kilometers beneath the crust. This idea is astonishing when you consider Pluto's environment. The average surface temperature hovers near 230 degrees Celsius, cold enough to freeze even the gases we breathe on Earth into solid ice. Sunlight is too faint to warm its ground, and Pluto is too small to hold on to much internal heat. By all logic, the world should be frozen solid, inert, and silent for billions of years. And yet, the data tell a different story. New Horizons revealed a surface far younger and more dynamic than expected. Smooth plains without craters, ridges and troughs as if the land itself had shifted, and faint hints of movement within the great icy heart. For a body at the edge of the solar system, this is extraordinary. It suggests that Pluto has not gone cold all the way through, that deep inside there is still energy, still heat, perhaps even liquid water. And where there is liquid water, we cannot help but ask, Could there also be life? For scientists, the search is cautious. No probe has drilled through Pluto's ice, no instrument has tasted the hidden waters. But for storytellers, and for anyone lying awake at night wondering if we are alone, Pluto offers a possibility too beautiful to ignore. Imagine a dark ocean, sealed away since the birth of the solar system. Imagine chemistry still unfolding there, molecules colliding in the black water. Imagine tiny forms of life, simple, patient, and unseen, enduring in silence, kept alive not by sunlight, but by the faint warmth of Pluto's core. Here, we linger with this possibility, because in the vast quiet of space, even the smallest whisper of life is enough to change everything we know about the cosmos. And so our journey begins with a frozen heart, a hidden ocean, and a question that glows faintly at the edge of the night. To understand why so many scientists suspect a hidden ocean beneath Pluto's frozen shell, we need to look closely at the strange details revealed by New Horizons. When its cameras swept across Sputnik Planitia, they captured a surface that looked unexpectedly young, unlike the crater-scarred faces of old. In active worlds, much of Pluto's heart appeared smooth, as if refreshed in recent geological time. The lack of impact craters suggests that this region has been resurfaced, possibly within the last few tens of millions of years, a blink of an eye compared to the age of the solar system. The key lies in the patterns etched across the plane. Sputnik Planitia is decorated with broad polygonal shapes, some stretching over 30 kilometers wide. To the untrained eye, they look like giant tiles fitted together. To planetary scientists, they are signs of convection cells, slow churning movement of nitrogen ice. Just as hot soup on Earth circulates with rolling currents, Pluto's nitrogen ice appears to rise and sink over spans of thousands of years. This is not something that happens on a world frozen to its core. It requires heat from below, warmth sufficient to keep the ice pliable, slowly overturning. But where would such heat come from, on a world so far from the sun? One possibility is the radioactive decay of elements like uranium and thorium, locked within Pluto's rocky core. Even though the amounts are tiny, the decay releases steady warmth over billions of years. Another possibility is that beneath the crust, liquid water remains not pure water, but water laced with salts and ammonia, which lowers its freezing point. This hidden ocean could provide the buoyancy and heat conduction needed to keep Sputnik Planitia in motion. Gravity adds another clue. By mapping Pluto's orientation and balancing forces, researchers noticed that Sputnik Planitia sits almost directly opposite Pluto's largest moon, Charon. This alignment suggests that the heart is not just a shallow dent on the surface, but a deep, heavy feature, heavy enough that Pluto's rotation gradually turned it to face Charon. A liquid ocean beneath the ice, denser than solid nitrogen alone, would help explain this gravitational tug. Put together, these lines of evidence tell a compelling story. Pluto may not be a frozen relic, but a layered world. Crust of nitrogen ice on top, water ice mountains beneath, and, hidden deeper still, a liquid ocean sloshing slowly in darkness. No one can drill through kilometers of ice to prove it, at least not yet, but the indirect signs line up like breadcrumbs leading into the deep. And if an ocean is there, what might it mean? On Earth, life seems to cling wherever liquid water and energy meet. In the crushing depths of our oceans, around hydrothermal vents where sunlight never reaches, entire ecosystems thrive on chemistry alone. They do not need warmth from the sunday. They rely on reactions between rock and water, on the steady release of chemical energy from Earth's interior. Pluto, improbably, may host a similar setup. Its rocky core could still be releasing heat and minerals into the bottom of its ocean. The ice above, though frigid, would act as a lid, sealing the water in, protecting it from the vacuum of space. Within that black ocean, molecules could combine, break apart, and combine again. Over time, perhaps they assembled into simple forms of life. We cannot know yet, but the possibility itself changes Pluto in our imagination. Once dismissed as a frozen afterthought, it becomes instead a secret world, quiet, dark, and maybe alive. To imagine standing on Pluto is to imagine silence in its purest form. The air is almost absent, the cold so deep it burns, and the sun hangs in the sky as nothing more than a bright star. Around you rise mountains made of water ice, as hard as granite, their peaks glinting faintly in the distant glow. Sputnik Planitia would stretch before you like an endless frozen plain, gleaming white beneath the weak light. To the eye, it looks unmoving. To the mind, it whispers of motion below a slow, hidden rhythm beating across millions of years. That hidden rhythm is what fascinates scientists and dreamers alike. It suggests that Pluto is not merely a fossil of the solar system, a frozen solid since its birth, but a layered world, alive in subtle ways. Beneath its surface crust, the ocean, if it exists, would be locked in perpetual night. No starlight would ever reach it, no day or season to mark the passage of time. Yet it could persist, sealed under kilometers of ice, sustained by the faint warmth of radioactive decay and the chemistry of rock and water. It is humbling to think that life, if it ever arose there, would have known nothing of the stars. A microbe in Pluto's ocean would never see a sunrise, never glimpse the Milky Way. Its universe would be liquid blackness, punctuated by minerals and chemical gradients. And yet, to that life, if it exists, such darkness would be enough. It would be home. In this way, Pluto becomes more than a curiosity at the edge of the solar system. It becomes a lesson that life does not always bloom in sunlight or in familiar conditions. Sometimes it waits in silence, in places we once dismissed as barren. Sometimes the heart of a lonely world beats quietly where no one expected it. For us tonight, drifting in thought here on the sleepy explorer, Pluto's frozen heart is both a scientific mystery and a metaphor. It reminds us that appearances can deceive, a cold surface can hide warmth, a distant, demoted planet can still matter deeply, a silent plain of ice can hold an ocean that whispers across the ages. We leave this part of the journey with a picture lingering in the mind, Pluto's vast heart, glowing faintly at the edge of the sun's reach, and beneath it, perhaps, an ocean that has never seen the stars, yet has endured in silence for billions of years. Our story, however, does not end here. To truly understand Pluto, we must drift backward into history, into the human imagination that first glimpsed this icy world. We'll return to 1930, when a young astronomer scanned the sky and discovered a wandering point of light. A discovery that would not only expand our solar system, but also reveal how deeply Pluto would steal our imagination. Long before spacecraft carried cameras to the outer reaches of the solar system, Pluto was already haunting the dreams of astronomers. At the end of the 19th century, subtle irregularities in Neptune's orbit suggested that something else might be tugging at it, an unseen world, far beyond the known planets. Percival Lowell, the wealthy founder of Lowell Observatory in Arizona, called it Planet X. He imagined it as a massive hidden planet, waiting to be found at the edge of the solar system. For more than a decade, he searched the skies with his observatory's telescopes, calculating and recalculating where this mysterious body might be. Lowell never lived to see the answer. He died in 1916, his dream unfinished, his Planet X unconfirmed. But his observatory lived on, and so did his question. By the late 1922, the task of hunting for this hidden planet fell to a young farm boy turned astronomer, Clyde Tombaugh. Tombaugh had grown up in Kansas, far from the professional circles of astronomy. He had built his own telescopes by hand, grinding lenses and polishing mirrors with patience and determination. When Lowell Observatory saw his sketches of Mars and Jupiter remarkably detailed for an amateur, they offered him a job. He was just 24 years old when he began the search for Planet X in earnest. Tombaugh's method was painstaking. He used a technique called a blink comparator, a machine that allowed him to flip quickly between two photographs of the same patch of sky, taken days apart. Against the fixed background of stars, a moving planet would appear to jump, flickering back and forth. Night after night, Tombaugh exposed glass photographic plates of the heavens, then spent long days hunched over the comparator, eyes straining for the faintest sign of motion. And then, in February of 1930, he saw it, a tiny dot of light shifting slightly against the stars. It was not an asteroid, not a known comet, but something farther, slower, steadier. Within weeks, the news spread around the world. Humanity had found a new planet, the 9th in the solar system. The discovery carried a thrill unlike any other. For the first time in history, an American observatory had found a planet, and a young unknown astronomer had risen overnight to international fame. Newspapers celebrated, classrooms updated their diagrams, and the boundaries of the solar system had suddenly stretched farther than before. The naming of this new world added another layer of magic. An 11-year-old girl in Oxford, England, named Venetia Burney, suggested the name Pluto after the Roman god of the underworld, ruler of shadows and hidden places. It was perfect, short, powerful, and symbolic of a world lurking in the darkness. The choice carried even more charm because its first two letters, P and L, echoed the initials of Percival Lowell, whose dream had inspired the search. From the very beginning, Pluto captured not only scientific attention but also human imagination. It was small, faint, almost invisible, yet it suddenly belonged to our family of worlds. And in that instant, the solar system felt a little larger, a little more mysterious, and a little more alive. In the first flush of excitement after 1930, Pluto was celebrated as the proud 9th planet. Textbooks were updated, solar system models were rebuilt, and children grew up memorizing its name at the far end of the planetary lineup. For decades, Pluto's discovery was not just an astronomical achievement, but also a cultural touchstone, a reminder that the universe was still full of hidden surprises. But as the years passed, questions began to emerge. Pluto was faint, distant, and stubbornly elusive. Even with the best telescopes of the mid-21st century, it remained only a blurry speck of light. Astronomers could measure its brightness, but brightness alone could be deceptive. If Pluto's surface reflected light well, it might be small. If it was darker, it could be larger. Early estimates of its size ranged wildly. Some thought it might be bigger than Earth. Others suggested it was closer to the size of Mars. The truth, however, was far stranger. Gradually, observations revealed that Pluto was much smaller than anyone had hoped. By the 1972nd, astronomers realized it was only about 1/5 the size of Earth, tinier than our own moon. Later measurements placed its diameter at just 2,377 kilometers. Its mass was even more humbling, only about 0.2% of Earth's. For a planet expected to account for the orbital irregularities of Neptune, Pluto was simply too small to do the job. The problem deepened in 1978, when astronomers James Christie and Robert Harrington discovered Pluto's largest moon, Charon. By studying the orbital dance between Pluto and Charon, scientists could calculate Pluto's true mass with precision. The numbers confirmed it. Pluto was not the massive Planet X Lowell had imagined. Instead, it was a lightweight, a tiny icy body in a vast, dark neighborhood. Still, Pluto held on to its planetary crown. Its discovery was too iconic, its presence in classrooms too beloved, to be easily dismissed. For a time, science and sentiment walked hand in hand. Astronomers continued to list Pluto as the 9th planet, even as they whispered among themselves that it didn't quite fit. And then, in the early 1992nd, new discoveries began to erode Pluto's status even further. Astronomers started finding other icy bodies beyond Neptune, in a region now known as the Kuiper Belt. Some of these worlds, like Quaoar, Haumea and Makemake, were surprisingly large. In 2005, the discovery of Eris, a world initially thought to be bigger than Pluto, brought the debate to a breaking point. If Pluto was a planet, then surely Eris deserved to be one too, along with many other similar bodies. Suddenly, the solar system threatened to expand to dozens, even hundreds of planets. In 2006, the International Astronomical Union, IA, made its controversial decision. Pluto would no longer be considered a full-fledged planet. Instead, it would be reclassified as a dwarf planet, sharing its category with Eris, Haumea, Makemake, and Ceres in the asteroid belt. The reasoning was clear: to be a planet, a body must clear its orbit of other debris, something Pluto, small and surrounded by Kuiper belt neighbours, simply could not do. The world reacted with a mix of shock and grief. For many, Pluto was more than a scientific label. It was a childhood friend, the plucky little planet at the edge of everything. School children wrote angry letters. Cartoonists drew Pluto with tears in its eyes. Even some astronomers protested, arguing that the new definition was unfair and inconsistent. Yet Pluto's demotion, painful though it was, did not make it less fascinating. If anything, it added to its mystique. The smallest, strangest member of our planetary family had been cast out, but in the process, it became a symbol of how science evolves, of how definitions change, and of how wonder survives classification. For all the scientific debates, Pluto never truly belonged only to astronomers. From the moment of its discovery, it spilled into culture, language, and imagination. In 1930, the same year Pluto was announced, Walt Disney introduced a cheerful cartoon dog with the very same name. Whether coincidence or tribute, the association stuck, and Pluto became a household word, known to millions of children, not for its icy orbit, but for wagging its tail on Saturday mornings. Writers and artists also embraced this lonely little world. Science fiction novels painted Pluto as the frontier of space, a last outpost before the stars. Comic books depicted it as a frozen fortress for alien civilizations. Even in music and poetry, Pluto appeared as a symbol of exile and mystery, a place that existed at the edge of maps and meanings. In the collective imagination, Pluto was not just cold and distant. It was the stage for stories about boundaries, endings, and the unknown. Its very smallness, in fact, made it more beloved. Unlike the giant worlds of Jupiter and Saturn or the blinding brilliance of Venus, Pluto was tiny, overlooked, and misunderstood. Children could identify with it. Dreamers could sympathize. When Pluto was demoted in 2006, the public reaction was so emotional because Pluto was never just a planet. It was the underdog. And in every story, the underdog is the one we root for. Even within science, Pluto retained its pull. Astronomers argued fiercely at conferences. Some refused to update their lecture slides. Others wore t-shirts proclaiming, "Pluto is still a planet." The debate spilled far beyond academic journals into late-night talk shows, newspaper editorials, even political speeches. It was as if Pluto had slipped free of definitions altogether and entered the realm of myth, not as a god, but as a small frozen world that somehow mattered more than its size could ever justify. And then, in 2015, Pluto gave us a gift. After a 9-year journey of more than 3 billion miles, NASA's New Horizons spacecraft swept past the dwarf planet and revealed it for the first time in breathtaking detail. The blurry dot became a world. Mountains of water ice towered 3 kilometers high, dark streaks stretched across ancient plains, and at the center of it all, Sputnik Planitia shone like a beating heart. In that moment, Pluto stole our imagination all over again. For decades, it had been a question mark. Now it was a landscape, strange, haunting, alive with texture and possibility. The debates over names and categories faded for a time, drowned out by awe. It no longer mattered what we called Pluto. What mattered was what it was showing us. For scientists, those images raised profound questions about geology, heat, and hidden oceans. For the rest of us, they simply reminded us of wonder, that at the farthest edge of our neighborhood, a tiny world could still astonish us. still whisper that the universe has secrets left to share. And so, as we leave this chapter of discovery and debate, we drift forward into the next part of our journey. We will explore Pluto's surface in detail, the scars and plains, the icy mountains and convecting ices that make up its cold, mysterious geography. For in its landscapes, carved by forces we barely understand, lie the clearest hints of what may stir beneath, the secret ocean that turns Pluto from a frozen relic into a living world. When the New Horizons spacecraft finally reached Pluto in July 2015, after a journey of more than 9 years and 3 billion miles, the world held its breath. Until then, Pluto had been little more than a blur, a smudge of light through even the most powerful telescopes. Entire generations of schoolchildren memorized its place in the solar system without ever seeing it as anything more than a grainy dot. But on that summer day, humanity's picture of Pluto transformed. What had once been a vague speck sharpened into a planet-like world, painted with colours of cream and copper, etched with valleys, mountains and plains. At the very centre of those first iconic images was a feature so striking that it instantly became Pluto's signature, a vast, gleaming heart of ice. Astronomers named this bright region Tombor Regio, in honour of Clyde Tombor, the young farm boy who discovered Pluto in 1930. Its western half is dominated by Sputnik Planitia, a massive basin filled with nitrogen ice that glows pale against the darker surroundings. It is one of the most recognizable landscapes in the solar system, large enough to be seen in detail from nearly 5 billion kilometers away. To the casual eye, Sputnik Planitia looks like a symbol carved for us to see a cosmic valentine sent from the edge of the sun's light. But for scientists it is much more, an active landscape, reshaping itself in slow motion. New Horizons revealed its surface broken into enormous polygons, each dozens of kilometers across. These patterns are not random. They are the signatures of convection, where nitrogen ice slowly rises and falls like dough in a colossal oven, driven by heat from below. Around the edges of the plain, strange dark streaks stretch across the ice, like the brushstrokes of an invisible painter. Some are likely deposits of darker material blown in by winds or carried by seasonal frosts. Others may mark the paths of glaciers, flowing sluggishly out of Sputnik Planitia and spilling into surrounding valleys. The whole region seems to be alive, not in the sense of biology, but in the sense of geology, a world reshaping itself under forces we are only beginning to understand. And then there are the mountains. Towering 3 to 4 kilometers high, they are not made of rock but of water, ice frozen so hard that it behaves like stone. With names like Norgay Montes and Hillary Montes, these peaks rise like jagged fortresses along the rim of Sputnik Planitia. Their very existence is a surprise. Pluto is far too small to hold on to the kind of heat that builds mountains through tectonics. And yet, here they are solid, immense, sculpted by processes that defy our expectations. Elsewhere, New Horizons revealed darker plains marked with ancient craters, suggesting that while some parts of Pluto are geologically young, others bear the scars of deep time. The contrast is stunning. One hemisphere looks old and battered, another fresh and restless. It is as if Pluto wears two faces, one frozen in history, the other whispering that something inside is still moving. For planetary cartographers, this was a revelation. In the space of a single day, Pluto went from being a dot to a detailed world map. We could trace valleys, sketch mountains, and chart icy plains. We could, for the first time, speak of Pluto not just as an object, but as a landscape. And in that landscape, clues pointed again and again towards something hidden below heat, motion, perhaps even a secret ocean. The closer scientists examined Pluto's surface, the stranger it became. Sputnik, Planitia, was not just a smooth basin of ice, but a place of motion and layering. Within the bright nitrogen plain, faint troughs divide the polygonal cells, suggesting that the ice is slowly overturning. At the edges, glaciers appear to creep outward, spilling through mountain passes into neighboring terrain. Unlike Earth's glaciers of water ice, these are rivers of nitrogen, creeping in silence under an alien sky. The sheer scale of these flows is breathtaking. Some valleys carved by nitrogen glaciers stretch for hundreds of kilometers, their floors polished smooth as if sculpted by a careful hand. Along their paths lie deposits of darker material, possibly organic compounds created when ultraviolet light from the distant sun breaks apart methane in Pluto's atmosphere. These compounds, called tholins, settle across the surface, tinting Pluto with hues of red and brown. Against the pale brilliance of Sputnik Planitia, they stand out like brushstrokes on a cosmic canvas. Surrounding the heart, the terrain tells a very different story. To the east of Sputnik Planitia, New Horizons captured images of ancient cratered plains regions, battered by billions of years of impacts, their surfaces left largely untouched since the early days of the solar system. The craters there are deep and jagged, filled with shadows that have likely stood unchanged for eons. In these places, Pluto looks like the fossilized relic we once imagined it to be, cold, silent, unchanging. And yet, just a short distance away, the landscape transforms again. In the dark expanse known as Cthulhu Regio, long, snaking ridges stretch across the surface. These are thought to be massive ice ridges or dunes, formed by winds whispering across Pluto's thin atmosphere. The region is coated in tholins, giving it a reddish-brown hue that contrasts starkly with the bright heart nearby. Cthulhu's darkness makes Sputnik Planitia glow even more brilliantly, the two halves of Pluto's face locked in a striking duality, light and shadow, youth and age. To the northwest, New Horizons revealed chaotic mountain blocks scattered like icebergs frozen in place. Some are dozens of kilometers across, jumbled together as though broken free from Pluto's crust and carried by the slow creep of nitrogen ice. These features suggest that Sputnik Planitia is not a static plain, but a dynamic basin that swallows and recycles chunks of Pluto's icy shell. Even in the deep freeze of the Kuiper Belt, Pluto's surface shows signs of renewal, a quiet but persistent reshaping of its geography. This juxtaposition, ancient craters beside fresh plains, dark ridges beside gleaming ice, paints Pluto as a world of contrasts. It is neither fully alive nor fully dead. Instead, it is caught in a delicate balance, its surface frozen in some places, restless in others. For planetary scientists, this is thrilling. A world once dismissed as inert now reveals itself as geologically diverse, with processes both familiar and alien. And beneath these processes lies the deeper question: what drives them? For many, the answer circles back to the possibility of heat beneath the crust, and with it, a hidden ocean. Every glacier that creeps, every polygon that overturns, every mountain block that drifts is a clue, hinting that Pluto's heart may not be cold stone after all, but the thin shell above a restless interior. As the images from New Horizons streamed back to Earth, the story of Pluto's surface came into focus like a slowly developing photograph. What they revealed was not a monotonous ice ball, but a world of astonishing diversity. On one side, ancient craters whisper of the solar system's violent youth, scars left unhealed for billions of years. On the other, the gleaming expanse of Sputnik Planitia speaks of motion and renewal, a place where ice circulates, glaciers creep, and mountains drift like frozen ships. Taken together, these regions show Pluto as a planet of dual identities. One face belongs to deep time, weathered, cratered, cloaked in tholins that redden its surface like rust on ancient metal. The other face is startlingly young, polished, bright, still reshaped by forces from within. Few worlds in our solar system present such a dramatic contrast, and fewer still at Pluto's size and distance. For planetary scientists, this duality is a puzzle that refuses to sit still. If Pluto were truly frozen to its core, Its surface should look uniformly old, every region scarred with craters like the Moon or Mercury. Instead, parts of Pluto appear renewed, as though the world itself is still alive, still reshaping its crust in defiance of the cold. Something is stirring beneath the ice, subtle but powerful enough to leave fingerprints on the surface. And this is what makes Pluto's cartography so compelling. Each plain, each ridge, each mountain tells not only a story of surface geology, but also a deeper tale of what may lie hidden below. The convection patterns in Sputnik Planitia hint at heat rising from within. The jumbled mountain blocks suggest a crust floating over something softer. The glaciers, creeping outward, imply a reservoir of mobile ice feeding their slow advance. It is as though Pluto is whispering its secrets in fragments, scattered across its surface, daring us to piece them together. And when we do, the picture points toward the same haunting possibility, that beneath the frozen crust, Pluto may hold an ocean. For us here tonight, on the Sleepy Explorer, these landscapes are more than data. They are reminders that beauty thrives even in the loneliest corners of space. A frozen heart can still beat. A tiny, distant world can still surprise us with its complexity. And perhaps most humbling of all, a place we once dismissed as an afterthought can instead rise as one of the solar system's most fascinating realms. As we leave Pluto's surface map behind, we carry with us the clues it has etched into ice. In the next part of our journey, we'll dive beneath those clues into the signals that suggest a hidden ocean is not just a dream, but a scientific possibility. What evidence convinces scientists that liquid water might still linger in the dark depths of Pluto? And what might that ocean mean for the question that has haunted us all along? Could there be life? When New Horizons swept past Pluto in 2015, its cameras didn't just capture beauty, they captured puzzles. On the smooth face of Sputnik Planitia, scientists noticed not only the great polygonal cells of convection, but also subtle lines, fractures slicing through the ice. Some ran for hundreds of kilometers, as though the crust had stretched and cracked under hidden pressure. In other places, the ground appeared to have bulged, uplifted into domes or ridges that seemed too large to be explained by surface processes alone. To planetary geologists, these patterns were whispers of something stirring deep below. On Earth, cracks and uplifts often mark the movement of water or magma beneath the crust, pushing upward, forcing the surface to adjust. On Pluto, no magma should exist. The world is far too cold. That leaves another candidate, liquid water trapped under kilometers of ice, pressing outward as it shifts, freezes, or expands. The idea is both daring and surprisingly plausible. If Pluto's ocean exists, it is sealed beneath an ice shell, perhaps 200 kilometers thick. Over billions of years, as parts of that ocean freeze, they would expand slightly just as water does when it turns to ice. That expansion would push upward, stressing the crust, carving cracks that could stretch across entire regions. Conversely, if the ice shell thins or shifts, the crust could sag, leaving depressions and troughs. Both uplift and collapse become possible when a hidden ocean is at work. Another clue comes from Pluto's overall shape and gravity. Sputnik Planitia sits in such a way that it seems to have reoriented Pluto's entire body, slowly rolling the dwarf planet over time, so that the basin now faces directly toward Charon. This kind of reorientation, called true polar wander, requires a massive, dense feature lurking beneath the surface. Solid ice alone would not suffice. A liquid ocean denser than the crust above it could provide the gravitational weight needed to turn Pluto like a slow-spinning top. For many scientists, these clues do not yet amount to proof. They are like shadows at the edge of vision, suggestive but not conclusive. Still, they form a pattern too consistent to ignore. Cracks, bulges, density anomalies, and reorientation all whisper the same possibility. Pluto's interior is not entirely frozen. Somewhere in the darkness, liquid may still linger. For us listening tonight, The image is haunting. Imagine standing on the rim of Sputnik Planitia, gazing across the silent plain, and realizing that far below your feet, hundreds of kilometers beneath the crust, there could be an ocean stretching wider than any on Earth, an ocean that has never seen sunlight, never touched open air, yet presses upward, leaving faint signatures carved into the surface for us to read. It is a reminder that even in places we once called dead, the evidence for hidden vitality can be written in ice. And the more carefully we listen, the more those signals seem to grow louder. The fractures across Pluto's surface are more than just scars. They are patterns that tell a story. Some stretch for hundreds of kilometers, cutting through ridges and plains alike. Others form networks, like cracks in drying mud, but on a scale so vast it boggles the imagination. On Earth, such fractures often mark places where material below the surface is shifting, expanding, freezing, or moving against the crust. On Pluto, the explanation most consistent with these cracks is the slow freezing of a hidden ocean. When liquid water turns to ice, it expands. If Pluto's internal ocean has been gradually freezing over the last billions of years, it would push outward against the crust. That pressure would not explode the surface, but it would stress the ice shell until it fractured. The result? Enormous cracks like those seen on Pluto's plains, visible reminders that something inside is still changing. Then, there are the strange uplifts. In several regions, new horizons revealed mounds and domes, features that rise gently above the surrounding terrain. Some scientists interpret these as places where subsurface material, possibly pockets of liquid mixed with ammonia or salts, has pressed upward. On Earth, volcanoes and geysers are the dramatic versions of this process, where molten rock or water bursts through the surface. On Pluto, the cold keeps everything subdued. Instead of fiery eruptions, we may be seeing the frozen fingerprints of slow underground swelling, cryovolcanism expressed not as lava, but as bulges in nitrogen and water ice. The strongest clue, however, comes from Pluto's orientation in space. Sputnik Planitia sits almost directly opposite Pluto's moon Charon. This is no coincidence. Over millions of years, Pluto seems to have rotated not by spinning faster or slower, but by slowly rolling its body so that the basin always faces Charon. Scientists call this phenomenon true polar wander. It happens when a planet's mass distribution shifts, forcing it to realign to keep balance. For Sputnik Planitia to cause such a reorientation, it must be unusually heavy. But here lies the paradox. Nitrogen ice, which fills the basin, is not dense enough to account for the weight. If anything, it should make the basin lighter. Something beneath must be denser, anchoring the region like a hidden weight. A subsurface ocean, salty and liquid, would provide exactly the mass needed to explain the anomaly. Without it, the math doesn't add up. Piece by piece, the evidence gathers. Cracks that mark expansion, domes that hint at internal pressure, and polar wander that demands hidden density. None of these proves the ocean beyond doubt, but together they form a chorus of indirect signals, each pointing toward the same conclusion. Pluto's interior is layered, complex, and not entirely frozen. To think of an ocean beneath Pluto is to stretch our imagination across extremes. On the surface, the temperature is nearly 230 degrees Celsius. The air is so thin it could not carry a whisper. The sun is no more than a bright star, casting weak shadows. And yet, far below there may be liquid water, the same substance that fills our oceans and shapes our own lives. It is this tension between the frozen silence above and the possible ocean below that makes Pluto such a compelling mystery. The surface tells us one story, but the fractures, uplifts, and gravity tell another, and the second story whispers that Pluto, against all odds, may still carry a sea in its heart. For decades, Pluto was thought to be a frozen relic, a world locked in silence since the dawn of the solar system. The cracks, bulges, and gravitational anomalies revealed by New Horizons have changed that picture forever. They do not scream their message, they whisper it. Subtle lines across a plain, the gentle dome of uplifted ice, the slow reorientation of a planet's body, all are quiet signs, easy to overlook, and yet together they speak with one voice. Pluto is more complicated, more alive than we once believed. Skeptics remain cautious. They remind us that every clue has alternative explanations. Fractures might arise from stresses unrelated to freezing oceans. Uplifts could form from unusual patterns of ice flow. Polar wander might involve processes we don't yet understand, but science does not rest only on individual clues. It builds strength from converging lines of evidence, and on Pluto, those lines seem to converge toward the same haunting conclusion. Beneath the ice, water may still move. The implications reach far beyond Pluto itself. If a world so small, so distant, can keep a liquid ocean alive, then oceans may be far more common in the universe than we ever dared imagine. The solar system could be filled with hidden seas not just on Europa and Enceladus, but on Triton, on dwarf planets in the Kuiper Belt, perhaps even on worlds yet undiscovered. Each one could carry the potential, however slim, for life. For us tonight, drifting in thought here on the Sleepy Explorer, there is a quiet comfort in that idea. It suggests that life does not need warmth and sunlight, blue skies and fertile soil. It may only need water, energy, and time, and those ingredients may be scattered far more widely than we once thought. So we close this chapter with a shift in perspective. Pluto is no longer only a distant ice ball. It is a world of signals, cracks across its plains, bulges in its crust, a weight hidden in its heart, each one a piece of evidence that something remarkable could lie beneath. From here, our thoughts drift toward, we will dive deeper into that question. If Pluto truly holds a hidden ocean, how does it remain liquid in such an impossibly cold environment? What forces could keep water from freezing solid over billions of years? The answers, as we'll see, involve chemistry, radiation, and the strange physics of ice forces that may keep Pluto's ocean alive even in the darkest corner of the sun's reach. At first glance, the idea of liquid water surviving on Pluto seems impossible. The surface is colder than almost anywhere else in the solar system, averaging 230 degrees Celsius. In that bitter cold, nitrogen and methane gases here on Earth lie frozen solid on the ground. Even carbon monoxide, a gas so volatile that it evaporates in a flash on Earth, becomes part of Pluto's icy crust. If Pluto's surface is this cold, how could an ocean of liquid water still exist far below? Shouldn't every drop have frozen solid eons ago? This question is the heart of Pluto's mystery, and the answer, surprisingly, lies not in the faint light of the distant sun, but in Pluto itself. Deep in its rocky core, Pluto still carries the embers of its birth. When the solar system was young, heavy elements like uranium, thorium, and potassium sank into the rocky centers of forming worlds. Over billions of years, those elements have quietly decayed, releasing a steady trickle of heat. On Earth, this radioactive warmth drives part of our plate tectonics and keeps our mantle active. On Pluto, though the amounts are far smaller, they may be just enough to keep water from freezing entirely. Think of Pluto's interior as a slow-burning stove, one that never blazes but never goes out. The heat seeps upward from the rocky core, trapped by the thick, insulating shell of ice above. Left alone, that heat would eventually fade. But Pluto has another ally in the battle against freezing: chemistry. Water mixed with other substances doesn't behave the same as pure water. On Earth, when we scatter salt across an icy road, the ice melts, even though the temperature is below zero. The salt lowers the freezing point, allowing liquid to remain. On Pluto, salts and especially ammonia may play a similar role. Laboratory experiments show that ammonia can lower water's freezing point dramatically, allowing it to remain liquid at temperatures far colder than ordinary ice could survive. If Pluto's ocean contains ammonia, it could stay fluid even in the deep cold of the Kuiper Belt. The combination of internal heat and chemical antifreeze makes the impossible seem less unlikely. Instead of a world frozen through, Pluto may hold a slushy, salty, ammonia-rich ocean beneath its shell, dark, ancient, and still alive with slow motion. For us, listening in the quiet tonight, the image is strangely comforting. Even in the loneliest, coldest places, nature seems to find ways to preserve a spark of warmth. A planet does not need sunlight to keep a secret ocean alive. Sometimes all it needs is patience, time, and the faint, steady fire of its own heart. If Pluto truly shelters a hidden ocean, then chemistry is just as important as heat. Pure water alone would not survive for long in such extreme cold, but Pluto's ocean is not likely to be pure. Instead, it may be a cocktail of compounds, salts, ammonia, and other antifreeze-like chemicals that allow liquid to persist against impossible odds. On Earth, we see hints of this principle every winter. When roads turn icy, a sprinkling of salt keeps them clear by lowering the freezing point of water. Even as the air stays below zero, the salted water remains liquid. Now imagine the same trick, but on a planetary scale. Within Pluto's buried ocean, dissolved salts such as sodium chloride or magnesium sulfate could keep the water from freezing solid, allowing it to remain slushy and mobile for billions of years. Even more powerful than salt, though, is ammonia. This simple molecule, made of nitrogen and hydrogen, acts as a potent antifreeze. Mixtures of water and ammonia can stay liquid at temperatures tens of degrees colder than pure water. Laboratory studies suggest that an ocean rich in ammonia could remain fluid at temperatures as low as 100 or 120 degrees Celsius. Still unimaginably cold by Earth standards, but warm enough, compared to Pluto's 230 degrees Celsius surface, to make the difference between solid ice and flowing liquid. There is another player in this hidden drama, clathrate hydrates. These are strange crystalline cages of water molecules that trap gases like methane or nitrogen inside. On Pluto, clathrates may form in the ice shell, acting like an insulating blanket. They conduct heat poorly, slowing the escape of warmth from the interior. In effect, they could cap the ocean, keeping the heat generated in Pluto's rocky core locked inside for longer. Think of it as a world wrapped in layers of insulation. First comes the rocky core, quietly radiating heat. Above it, the ocean salty, ammonia-rich, reluctant to freeze. Over that lies the thick shell of water ice, strong and rigid, but studded with clathrate hydrates that trap heat below. And finally, on the surface, a skin of nitrogen ice reflects what little sunlight reaches Pluto, locking the world in shadow. With these layers combined, Pluto becomes something more than a frozen ball. It becomes a delicate balance of heat and chemistry, an intricate structure that has managed to preserve liquid water for billions of years. The system is not perfect. Parts of the ocean likely freeze over time, expanding and cracking the surface. But the fact that any part may remain liquid at all, after 4.5 billion years in the cold, is extraordinary. For scientists, this is not just a curiosity about Pluto. It is a lesson about resilience. If Pluto, with its tiny size and distance from the Sun, can protect an ocean, then other icy worlds may be doing the same. Life's habitats may be hidden in places we least expect, beneath shells of ice, in darkness, sustained not by sunlight but by chemistry and the stubbornness of physics. And for us, listening here in the quiet, the thought is soothing. Even in the coldest corners of the cosmos, warmth lingers. Even where everything looks silent, there may be motion deep within. The universe, it seems, has its own way of keeping secrets alive. To picture Pluto's hidden ocean, imagine a tiny ember wrapped in layers of blankets. The blankets are not made of fabric, but of ice and chemistry salts dissolving in water, ammonia softening the freeze, clathrate hydrates, trapping heat like quilted insulation. Together they hold onto the faint warmth leaking from Pluto's rocky heart, keeping part of the ocean liquid even as the surface lies locked at 230 degrees Celsius. It is a fragile arrangement. The ocean is not vast and open like Earth's seas. It is slow, heavy, and buried beneath hundreds of kilometers of ice. Parts of it have likely frozen over time, pressing upward and cracking the crust. Other regions may be thick with slush rather than liquid water. And yet, the very survival of any ocean at all in such a small and distant world feels miraculous. This survival carries a quiet lesson. Warmth does not always blaze like sunlight. Sometimes it endures as a whisper, patient and steady, hidden beneath obstacles. Pluto's ocean may not roar with tides or currents. It may simply exist, kept alive by persistence rather than power. And in that persistence, there is a kind of beauty, a reminder that life too can endure in the most unlikely places. For planetary scientists, the thought is electrifying. If Pluto can do this, then the outer solar system is likely filled with hidden seas. Europa, Enceladus, Titan, Triton, even dwarf planets scattered through the Kuiper belt. Oceans may be the rule rather than the exception, making the cosmos far wetter and perhaps more hospitable than we once imagined. For us tonight, it is enough simply to marvel, to think that beneath Pluto's frozen heart water may still flow, to realize that in the loneliest, coldest reaches of the sun's realm, warmth has not gone out completely. Pluto, demoted in name but exalted in mystery, keeps its secret flame alive. And as we drift onward in our story, we rise gently from beneath the ice toward Pluto's sky, because above its surface, something equally mysterious awaits, a thin blue haze, a fragile atmosphere that swells and fades with the seasons. In the next chapter, we will breathe with Pluto itself and listen to the quiet rhythm of a world that still exhales into the dark. When New Horizons turned its camera back toward Pluto, just after its closest approach in July 2015, the spacecraft caught a sight no one had truly expected. Against the black canvas of space, Pluto was rimmed with a halo, a soft, delicate glow of blue. The images stunned scientists and dreamers alike. Pluto, so small and distant, wore an atmosphere that shimmered like smoke in twilight. This fragile envelope is almost nothing by earthly standards. Stand on Pluto's surface, and the pressure of its air would be less than 100,000th of what you feel at sea level on Earth. And yet, thin as it is, the atmosphere gives Pluto something profound, the sense that it is still alive. Like a sleeping being that exhales slowly, Pluto seems to breathe. The air is composed mainly of nitrogen, making up more than 98% of its atmosphere. Mixed in are traces of methane and carbon monoxide gases that play an outsized role in shaping the world we see. In Pluto's bitter cold, these gases freeze into ice on the surface, only to sublimate back into gas when warmed, even slightly, by the distant Sunday. This delicate balance of freezing and sublimating is Pluto's breath, a cycle of inhalation and exhalation that changes with its 248-year orbit. The most ethereal part of this atmosphere is its haze. Instead of a single thin blanket, Pluto's haze forms in layers, at least 20 of them, stacked like gauze veils, reaching up more than 200 kilometers above the surface. These layers scatter sunlight, producing the ghostly blue glow that New Horizons captured. The blue comes not from the gases themselves, but from tholins, tiny particles born when ultraviolet light from the sun breaks apart methane and recombines it into complex organic molecules. Suspended in the air, these particles scatter light in the same way Earth's sky does at sunset, painting Pluto with an otherworldly aura. For the scientists studying these images, the haze was a revelation. For the rest of us, it was poetry, a dwarf planet at the edge of the solar system, wrapped in a veil of blue. To imagine Pluto's atmosphere is to imagine fragility itself, a breath so thin it could never sustain life as we know it, yet a breath that gives character, that whispers movement and change. Against the silence of space, Pluto exhales, and the haze drifts like incense across the darkness. Pluto's atmosphere is not fixed the way Earth's feels. Instead, it is in constant dialogue with the surface, ebbing and flowing with the planet's long orbit around the Sunday. At its farthest distance, nearly 7.4 billion kilometers away, Pluto is so cold that nitrogen, methane, and carbon monoxide condense and settle as frost across its plains. The air thins almost to nothing, and Pluto seems to fall asleep. But as it drifts closer, down to about 4.4 billion kilometers at perihelion, even the faintest touch of extra sunlight is enough to stir change. Surface ice begins to sublimate, molecules rise and float, and a fragile shroud of atmosphere swells outward once again. This process is Pluto's breath. A slow inhalation as gases freeze onto the surface, a slow exhalation as they escape back into the sky. Each cycle spans centuries, so patient and unhurried that it feels less like weather and more like the rhythm of a deep, cosmic meditation. The haze makes this rhythm visible. New Horizons showed us that Pluto's atmosphere is layered, with veils of particles stacked up like curtains in a dimly lit room. These layers may form as gravity waves ripple upward through the air, or as temperature gradients create distinct pockets where particles settle. Whatever their cause, they scatter light in such a way that Pluto looks surrounded by rings of pale mist, the concentric halos, glowing faintly against the dark. Seen from the surface, the effect would be magical. Imagine standing on Pluto at twilight, the sun a tiny ember near the horizon. Instead of darkness swallowing the sky, faint bands of haze would catch the weak sunlight, glowing blue like distant smoke. Above them, the stars would pierce through the thin veil, bright and sharp in the cold air. It would feel at once intimate and infinite, a sky so fragile you could almost believe it might shatter if you breathed too hard. For scientists, these hazes hold clues about chemistry at the edge of possibility. Methane molecules drifting upward are broken apart by ultraviolet sunlight, recombining into complex organics that then fall back to the surface. Over time, they paint Pluto with reddish-brown tholins, the same material that darkens regions like Cthulhu Regio. In this way, the atmosphere and the surface are forever linked. Pluto exhales molecules, sunlight transforms them, and they settle back like a dusting of pigment, colouring the land. It is a cycle of breath and renewal, played out not over hours or days, but across centuries and millennia. On Pluto, even breathing happens in geologic time. There is something profoundly moving about Pluto's thin breath. It is not a roaring wind like Jupiter's storms, nor a dense, nurturing atmosphere like Earth's. Instead, it is a veil, delicate, fleeting, almost transparent, and yet it is enough to remind us that Pluto is not still. It inhales as ices condense, it exhales as they sublimate. Across centuries, across the slow sweep of its 248-year orbit, Pluto continues this rhythm. To us, it looks like fragility, but in its persistence lies resilience. Even at the edge of the solar system, where sunlight is no stronger than moonlight on Earth, Pluto keeps its cycle alive. Even where air is thinner than any vacuum chamber on our planet, layers of haze rise, glow, and fall again. In its own way, Pluto has kept breathing for billions of years. For the dreamer, this breath is poetry. A dwarf planet demoted from planetary glory, yet wrapped in an atmosphere that paints it in blue. A world so small it could be overlooked, yet so complex that it wears a halo visible from billions of kilometers away. In the quiet of space, Pluto whispers with every molecule that escapes into its sky, "I am still here. I am still alive." And for the scientist, Pluto's breath is a signpost. The haze and chemistry tell us that active processes still shape this world. Its air may be thin, but it interacts with the surface, changes with the seasons, and deposits organics that could serve as the raw ingredients for life. Even here, in what seems like the unlikeliest of places, the atmosphere and the possibility of life are already intertwined. So as we leave Pluto's blue haze behind, we carry with us the image of a world that breathes. not with lungs or voice, but with ice and sunlight, sublimation and shadow, a planet's exhalation, painted in blue against the dark. As we drift toward, we will follow that thread deeper into the question that lingers beneath all of Pluto's mysteries. If there is indeed a hidden ocean sealed under its crust, and if its atmosphere continually supplies organic material, could Pluto's dark waters harbour life? In the silence below the ice, might there be something quietly alive, waiting to be found? If life cannot reach the sun, can it still survive? This question feels simple, yet it reshapes how we look at the cosmos. For most of human history, we assumed that sunlight was the spark of life. Plants drink it in, animals feed on plants, and the chain continues upward. Without light, there could be no warmth, no food, no life. But Earth itself has shown us that this assumption is not the full story. Consider Antarctica, where sunlight disappears for months at a time. Beneath thick ice sheets, microbes endure, using chemical energy instead of light. They live in subglacial lakes, sealed away for hundreds of thousands of years, thriving in water kept liquid only by pressure and geothermal heat. To these tiny organisms, the sun is irrelevant. Their universe is ice above, rock below, and water in between, a world not so different from what we imagine on Pluto. Even more dramatic are the ecosystems found at the bottom of Earth's oceans. In the blackness 2 kilometers below the surface, hydrothermal vents spew hot, mineral-rich water into the sea. Around these vents, life flourishes. Strange tube worms, ghostly crabs, translucent shrimp. They do not feed on sunlight. Instead, they rely on chemosynthesis bacteria that convert chemical energy from hydrogen sulfide into food. Entire communities grow in complete darkness, their survival proof that life can thrive without a single ray of sunday. These examples are our windows into what life on Pluto might resemble. Deep beneath its crust, in an ocean sealed away from the sun for billions of years, conditions may mirror those Antarctic lakes or hydrothermal vents. There would be no photosynthesis, no forests or fish, but there could be microbes, feeding not on light but on chemistry, drawing energy from interactions between water and Pluto's rocky core, perhaps releasing hydrogen or methane as byproducts. For scientists, the possibility is not outlandish. Life on Earth began simple, and some of its earliest forms may have resembled these chemosynthetic microbes. If life can take root in such environments here, why not there, in a place where water, chemistry and time have been quietly working together beneath a frozen sky? For us tonight, drifting with this thought, there is a strange comfort in imagining it. The idea that life does not need to bask in light, that it can exist in quiet corners, changes how we see the universe. It suggests that Pluto's hidden ocean might not be empty. It might carry its own fragile spark, waiting in silence, surviving in ways both alien and deeply familiar. The deep oceans of Earth may be the closest mirror we have to Pluto's hidden world. At hydrothermal vents along the mid-ocean ridges, scalding jets of water burst forth, loaded with sulfur and minerals from Earth's mantle. The surrounding darkness is absolute. No sunlight penetrates to these depths. Yet here, life not only exists but flourishes in astonishing variety. At the heart of these communities are chemosynthetic bacteria. Instead of photosynthesis, they perform a process called chemosynthesis, converting hydrogen sulfide, a gas toxic to most surface life, into usable energy. These microbes form the base of the food chain, feeding tube worms that grow meters long, shrimp with light-sensing patches on their backs, and crabs that cluster in ghostly crowds. Each life form is adapted not to light but to chemistry, their existence proof that energy itself is enough to sustain an ecosystem. Elsewhere, cold seeps on the ocean floor provide methane and other hydrocarbons as fuel. Bacteria consume these molecules, creating mats of microbial life that support mussels, clams, and even fish. In Antarctica's subglacial lakes, bacteria survive with nothing more than minerals dissolved in the water and a trickle of chemical reactions with the bedrock below. Taken together, these environments reveal a profound truth. Life is astonishingly versatile. It does not demand sunlight. It asks only for three things: liquid water, a source of energy, and the right chemistry. If those conditions are met, life can endure, even in silence and cold. On Pluto, the parallels are striking. Its rocky core could release heat and minerals into the base of its subsurface ocean, just as Earth's mantle does at vents. Ammonia and salts dissolved in the water could provide a stable environment for chemical reactions. Methane, abundant on Pluto's surface and in its atmosphere, could serve as raw material, breaking down and recombining in ways that microbes might exploit. The cycle might look something like this. Water interacts with minerals in Pluto's core, producing hydrogen. Microbes, if they exist, could consume that hydrogen, combining it with carbon compounds to generate energy. Their waste products could enrich the water, feeding new reactions, sustaining a tiny but self-sufficient ecosystem in the darkness. Would these organisms look anything like Earth's? Probably not. They would not need eyes or pigments. They would not build forests or reefs. Instead, they would exist at the scale of microbes, patient, resilient, perhaps clinging to cracks at the rocky bottom of the ocean. To us, they would be invisible without a microscope. Yet their existence would be revolutionary, proof that life can bloom not only under suns, but under ice, in the quietest corners of the cosmos. For the dreamer, this possibility is both humbling and hopeful. It means that the spark of life may not be rare. It may simply be hidden, waiting in places we have yet to look, to waiting, perhaps, on Pluto, breathing not with lungs, but with chemistry. The idea that life can survive without sunlight once felt like science fiction, but Earth has shown us otherwise. From Antarctic lakes sealed under kilometers of ice, to hydrothermal vents where superheated water meets the sea, to cold seeps that release methane in the deep, life has found a way. These places remind us that the sun is not the only spark. Sometimes chemistry alone is enough. If such resilience is possible here, why not there on Pluto, where water may lie hidden, where chemistry never stops? Perhaps in its buried ocean, microbes drift slowly, multiplying at a pace measured not in days but in centuries. Perhaps they anchor to rocky fissures, feeding on hydrogen released from Pluto's core. They would know no light, no sky, no stars, and yet, in their quiet existence, they would prove that life's most basic requirement is not sunlight but persistence. For us, imagining such beings is both humbling and hopeful. Humbling, because it expands our sense of what life can be. Hopeful, because it suggests that the universe may not be as empty as the night sky makes it seem. If Pluto, a tiny world on the edge of the solar system, might harbour even the simplest forms of life, then perhaps life is woven throughout the cosmos, scattered like embers waiting to be found. And so, as we close this chapter, we carry with us a new perspective. Life does not need to shine. It can whisper in darkness, hidden beneath ice, nourished by chemistry alone. As we drift toward, we will take this idea further. If Pluto does hold such life, how might it shape its environment? What kind of ecosystem could exist in eternal night? An ecology without sunlight, built on chemistry, silence, and time. Let us descend into that thought, into the possible ecology in the dark. Imagine lowering yourself into Pluto's hidden ocean. The ice shell above is kilometers thick, the water below utterly black. No sunlight has ever pierced this realm. The surface stars are a rumour, unknown to anything that might live here. At first glance it seems empty, a still abyss, colder and quieter than any ocean on Earth. But with patience, your eyes adjust to the idea of possibility. Slowly a picture begins to form. If life exists here, it would likely begin small. Picture the underside of Pluto's ice crust, a boundary where frozen nitrogen meets the faint warmth of the hidden sea. Along these surfaces, tiny microbes might cling in thin biofilms, forming mats that ripple gently in the slow currents. On Earth, similar biofilms cover rocks in caves and ice in Antarctica's subglacial lakes, where bacteria feed on trace minerals and chemical energy. On Pluto, these organisms would not photosynthesize. Instead, they would rely on chemosynthesis, using the slow trickle of nutrients leached from the ice above or minerals drifting up from the rocky core below. Over billions of years, such films could weave into fragile webs of life. They would not glow with color or movement, but they would change their environment subtly, altering the chemistry of the water, leaving residues on the ice, perhaps even releasing tiny bubbles of gas. To us, these would be almost invisible signs, but for Pluto, they would be the quiet heartbeat of a living ocean. The image may seem simple, but simplicity is powerful. On Earth, microbial mats were among the first ecosystems, shaping the atmosphere long before animals appeared. If Pluto harbors such life, it would not need grandeur to matter. Even the thinnest film of microbes, stretching across the underside of the ice, would transform this hidden ocean from a place of silence into a place of survival. In this vision, Pluto becomes more than frozen geology. It becomes a canvas painted not only by cracks and convection cells, but also by living threads, delicate, unseen, and enduring. Now let us sink deeper into this imagined sea, away from the cold ceiling of ice. The water here is dense, silent, heavy with time. In such a place, pockets of trapped gas could gather, forming bubbles of methane or hydrogen released slowly from Pluto's rocky core. On Earth, similar pockets appear in subglacial lakes or beneath permafrost, sealed for millennia until some shift lets them rise. On Pluto, these bubbles might serve as floating havens, tiny drifting capsules where microbes could cluster and endure. Picture one of these pockets, a fragile dome of gas, no larger than a cavern, suspended in the black water. Along its edges, microbes could line up like silent colonies, feeding on the very gases that sustain them. Methanogens, if they exist here, might consume hydrogen and carbon dioxide, exhaling methane as waste. Others could exploit chemical gradients, trading molecules in exchanges too small for us to see but enough to sustain a delicate balance. To the imagination, these pockets feel almost like lanterns in the abyss, not because they glow, the light has no meaning here, but because they represent centers of energy in an otherwise starved environment. Around them, the ocean would still be empty and dark, but within, life might flicker quietly, clinging to the thin line between chemistry and silence. Earth gives us analogies. In permafrost regions, scientists have drilled into ancient ice and found microbes still alive in air bubbles sealed for hundreds of thousands of years. In deep-sea sediments, organisms persist in tiny gas-filled pores, metabolizing at rates so slow that a single cell division might take centuries. If such endurance is possible here, in conditions already extreme, then perhaps it is not so far-fetched on Pluto. These imagined gas pockets turn the hidden ocean into something more than static water. They make it dynamic, patchy, punctuated by rare but vital oases. In a way, they echo the hydrothermal vents of Earth-concentrated islands of possibility scattered across an inhospitable expanse. To stumble upon one would be to stumble upon the very spark of survival in a place that seems otherwise lifeless. And in this vision, Pluto's ocean becomes not a uniform void, but an archipelago of hidden sanctuaries, tiny bubbles, silent but alive, drifting through the dark. And finally let us descend all the way to the bottom of Pluto's hidden ocean, the place where liquid water meets the rocky core. Here, in the cold and crushing pressure, we might imagine sediments rich in organics slowly accumulating over billions of years. Every particle drifting down from the haze above, every molecule altered by chemistry in the ocean itself, would eventually settle here, forming a dark floor layered with time. On Earth, sediments at the bottom of seas and lakes are anything but sterile. They are home to entire microbial worlds, fueled by decaying organic matter, slow chemical reactions, and the minerals seeping up from the crust below. Life here moves at a pace so languid it seems almost frozen. Microbes divide perhaps once a century, living within the tiniest of energy budgets. Yet they endure, turning the ocean floor into a quiet tapestry of persistence. On Pluto, a similar process could unfold. Organic particles created in the atmosphere, those reddish tholins born from sunlight breaking apart methane, might snow down over eons, filtering through cracks and eventually reaching the ocean. Mixed with salts and ammonia, these compounds could become food for microbes that wait patiently in the sediment. Hydrogen released from reactions in the rocky core could seep upward, offering another thread of energy. Slowly, invisibly, an entire ecosystem could root itself in the mud of a world that has never seen the sunday. It is tempting to think of this ocean floor as barren, but in the imagination it becomes alive in its own quiet way. Instead of coral reefs or forests, picture invisible mats of microbes carpeting the sediment, whispering in chemistry what they cannot say in light. Every grain of sand, every pore of mineral, might be a home. In such a world, survival is not about abundance but endurance, not about speed but patience. Taken together, these three visions, biofilms clinging to ice, gas pockets sheltering microbial oases, and sediments harbouring ancient colonies, form a picture of a possible ecology in the dark. Not an Earth-like biosphere, but a subtle hidden network of survival, a world without sunlight, yet not without life. And perhaps that is Pluto's quietest lesson, that life, if it exists here, does not shout, it whispers. It shapes its environment gently, invisibly, over spans of time so long that our minds can barely hold them. Carrying that image with us, we rise once more from Pluto's imagined ocean, carrying with us the vision of a hidden ecosystem that might be unfolding even now. The story continues. We will leave these speculative habitats and look upward again to Pluto's companions in space. Its largest moon, Charon, and its family of smaller satellites offer another window into Pluto's mysteries, and perhaps more clues about the forces that shape this distant world. When we speak of Pluto, we cannot tell its story alone, for circling just 19,000 kilometers away, closer than the distance from Earth to some of our satellites, is Charon, Pluto's largest moon. Yet to call Charon merely a moon feels incomplete. The two worlds are locked together in a way so unusual, so intimate, that astronomers often describe them not as planet and satellite, but as a double world. The secret lies in their proportions. Charon is about half the size of Pluto, with a diameter of 1,208 kilometers, compared to Pluto's 2,377. No other planet-moon pair in the solar system comes close to this ratio. Our own moon, though large, is only a quarter of Earth's size. Jupiter's Galilean moons, though immense, are tiny compared to their parent. But Pluto and Charon, they are partners almost equal in scale, more like two dancers clasping hands than a master and follower. Their bond is even more striking in how they move. Most moons orbit a point deep inside their planet's body, but Pluto and Charon both orbit a barycenter, a shared center of gravity that lies outside of Pluto itself. It is as if the two are forever circling an invisible point in space, locked together in an eternal dance. From Pluto's surface, Charon does not rise or set. It hangs fixed in the sky, always gazing down. And from Charon, Pluto does the same. The two worlds face each other in perpetual embrace, bound by gravity and time. How did such a rare partnership come to be? The leading theory suggests a giant collision in Pluto's distant past. Billions of years ago, a massive impactor may have struck Pluto, blasting debris into orbit that eventually coalesced into Charon. This story mirrors our own moon's origin, but with a twist. Charon did not become a small companion. It became nearly a twin, large enough to shift Pluto's balance, to change its very nature. The consequences of this bond run deep. Tidal forces between the two worlds long ago slowed their rotations, locking them into mutual synchronicity. Pluto's ocean, if it exists, may be stirred or even preserved by these tides, the gentle flexing of its interior keeping heat alive. And Charon, too, bears scars of this relationship, vast chasms and ridges across its surface, as though it, too, has been pulled and reshaped by the gravity of its partner. To think of Pluto and Charon is to think of two lonely wanderers at the edge of the solar system, bound together in a quiet waltz. Neither dominates, neither lets go. They are, in the truest sense, companions in the dark. When New Horizons passed by Pluto, it also swept its gaze across Charon, and what it revealed was a world with a story all its own. At first glance, Charon looks stark, its surface painted in shades of grey and muted brown, a reflection of water ice mixed with dark tholins. But the details tell a richer tale. Across its face runs a system of canyons so vast they dwarf the Grand Canyon of Earth. One chasm, known as Serenity Chasma, stretches nearly 1,800 kilometers long and plunges several kilometers deep. It is as if Charon's crust once cracked open, pulled apart by forces from within. Scientists believe these scars are evidence of ancient internal activity. Long ago, Charon may have possessed its own subsurface ocean. As it slowly froze, the expanding ice would have stretched the crust, tearing it open to create those colossal canyons. Today, the ocean is likely gone, but the memory remains, etched into the surface like wrinkles in an old face. Near Charon's northern pole lies a curious blot of reddish colour, informally named Mordor macula. This stain is thought to be created by methane escaping from Pluto's atmosphere, drifting across space, and freezing on Charon's surface before breaking down into tholins. In this way, Pluto and Charon are not only gravitational partners, but also chemical companions, sharing materials across their tiny gulf. The gravitational bond between the two worlds has had profound effects on both. Tidal forces long ago synchronized their rotations. Pluto always shows the same face to Charon, and Charon always shows the same face to Pluto. This dance of synchronicity creates stability, but it may also stir the worlds internally. On Pluto, the gentle kneading of tides could help keep its hidden ocean liquid. On Charon, it may once have driven internal heating strong enough to maintain its own ocean before it froze. The romance of this connection is undeniable. Most moons are servants to their planets, circling obediently, their presence barely noticed. But Charon is no mere follower. It is a partner, large enough to alter Pluto's destiny, to shape its tides, to catch its atmosphere on its poles. Together, they form not a planet and a moon, but a double world, each carrying the mark of the other. And in that double world, there is poetry. Two small icy bodies, overlooked and demoted, yet bound in an eternal dance. Their embrace has lasted for billions of years, and will continue long after we are gone. Out at the edge of the solar system, where loneliness might seem inevitable, Pluto and Charon remind us that even the smallest worlds can find companionship. To imagine Pluto and Charon together is to imagine a waltz at the edge of the solar system. No music plays, no lights shine, and yet the rhythm is perfect. Two worlds circling an invisible point in space, locked in step for billions of years. Unlike most planets and their moons, there is no master and servant here. Instead, there is balance, a double world, each shaping the other's destiny. From Pluto's surface, Charon never rises or sets. It hovers forever in the same place in the sky, a silent companion watching from above. From Charon, the view is the same. Pluto, hanging unmoving, its bright heart gleaming across the gulf. They are bound not only by gravity, but by time itself, locked in a gaze that has never broken and may never end. There is something tender in this arrangement, almost romantic. In the darkness where sunlight is little more than a spark, Pluto is not alone. Charon is always there, steady, enduring, keeping pace in the endless night. The two share more than motion, they share matter, as Pluto's atmosphere drifts across space and stains Charon's pole red. They share history, perhaps born from the same colossal collision. They even share fate, orbiting together at the edge of the sun's reach. For us, this dance is a reminder that companionship can take many forms. Even in the loneliest places, bonds can form, enduring against all odds. Pluto and Charon do not blaze like Jupiter and its moons, nor rule the sky like Earth and hers, but in their quiet, synchronized steps, they embody something rarer: partnership. And this partnership leads us naturally to a larger question. If Pluto may hold a hidden ocean beneath its heart, could Charon have once held one as well? Could there be an entire club of hidden oceans in the outer solar system, worlds of ice concealing seas of possibility? As we move toward, we will widen our gaze, looking not only at Pluto but at its kin, Europa, Enceladus, Titan, and others. Together, they form a secret society of oceans in the dark, each carrying the potential for life where we least expect it. Pluto may feel like an outlier, a lonely world on the farthest edge of the solar system, demoted from planethood and wrapped in endless cold. But when we look closer, Pluto begins to resemble not an exile, but a member of an extraordinary club. Across our cosmic neighborhood, several icy worlds appear to share its secret, vast oceans hidden beneath their frozen shells. Take Europa, one of Jupiter's moons. Beneath its cracked, ridged surface lies an ocean kept warm by tidal forces, stretching perhaps twice the volume of all Earth's seas combined. Jets of water sometimes spurt into space, carrying with them tantalizing hints of salts and organics. For decades, Europa has been considered one of the best places to search for extraterrestrial life. Or Enceladus, a small moon of Saturn no larger than England, yet astonishingly active. Its south pole bursts with geysers, fountains of water, ice shooting hundreds of kilometers into space. The Cassini spacecraft flew through those plumes and detected not only water vapor, but complex organic molecules. Here, in a place once dismissed as insignificant, we found signs of chemistry that could sustain life. And then there is Titan, Saturn's largest moon. Titan holds seas of liquid methane and ethane on its surface, while beneath its icy crust likely lies another ocean of liquid water mixed with ammonia. Titan is unique, a world that shows us both alien chemistry above and familiar water below. It reminds us that oceans can take many forms, and that habitability may not look the same everywhere. When we place Pluto among these worlds, a pattern emerges. They are scattered across the solar system, orbiting giant planets or drifting alone, yet all seem to share a hidden feature: seas locked away beneath ice. Oceans where life could take hold, shielded from harsh radiation, preserved across billions of years. Pluto, then, is not alone. It belongs to this club of hidden oceans, a secret fraternity of worlds that may prove the solar system is far more alive, or at least life-friendly than we once imagined. To include Pluto here is to shift our view, from a lonely dwarf planet to a potential kin of Europa, Enceladus, and Titan, a member of a family whose story is only just being written. What unites these distant worlds is not their surfaces, for each wears a different mask, but their interiors. Beneath Europa's smooth shell, Enceladus's cracked pole, Titan's orange haze, and Pluto's frozen heart, the same quiet secret may be kept: liquid water sustained against the odds. For Europa and Enceladus, it is gravity's pull that keeps the seas alive. The immense tug-of-war with Jupiter and Saturn flexes their interiors, heating them like clay warmed in a potter's hands. The result? Oceans that churn and flow despite the frigid cold of space. For Titan, ammonia mingled with water lowers the freezing point, while complex chemistry in its atmosphere rains down new organics to feed its hidden sea. Pluto is different. It has no giant planet to pull at it, no immense gravitational partner to stir its insides. Instead, it survives by its own quiet persistence. Heat from the slow decay of radioactive elements in its rocky core seeps outward, just enough to keep parts of its ocean from freezing solid. Salts and ammonia dissolved in the water may help keep it liquid, like antifreeze mixed into a car engine on a winter night. What gravity gives to Europa, Pluto must sustain by patience, and that is perhaps even more remarkable. This makes Pluto a unique voice in the choir of ocean worlds. It proves that hidden seas do not require the favour of giants. They can exist in solitude, maintained by the faintest of internal fires and the chemistry of ice. If Pluto has kept its ocean alive for over 4 billion years, then subsurface seas may be far more common than we dared to hope. There is also a kind of poetic symmetry in Pluto's membership. Once celebrated as the 9th planet and later demoted to dwarf status, it seemed cast out, diminished. Yet here, in the company of ocean worlds, Pluto regains significance. It joins a family that is not defined by size or category, but by possibility. Worlds as small as Enceladus and as large as Titan all belong, and Pluto stands among them, carrying its frozen heart and perhaps its hidden sea. In this way, Pluto's place in the club of hidden oceans is not just scientific, it is symbolic. It shows us that even a world written off as insignificant may conceal something vast, something that speaks to life itself. Step back for a moment and look at the pattern. Our solar system, once thought to be mostly barren, now seems threaded with oceans beneath ice. Europa, Enceladus, Titan, Ganymede, Callisto, and perhaps Pluto, all carrying hidden seas. Each world is like a locked chest, its key still undiscovered, but inside may lie the most precious of treasures, conditions where life could take hold. To think of them together is to see not isolation, but kinship. The giants of Jupiter and Saturn guard their ocean-bearing moons, while lonely Pluto guards its own, far from the warmth of the Sunday. Yet in their separation, they share a common story: water, finding ways to endure where it should not, warmth lasting longer than expected, chemistry unfolding in silence. The universe, it seems, does not need much to keep hope alive. For the dreamer, this realization is exhilarating. It suggests that life might not be the rare jewel we once believed, but a recurring motif in the symphony of worlds. And for the skeptic, it is an invitation to test, to probe, to challenge these ideas with sharper instruments and braver missions. Pluto's membership in this secret club reminds us that science is often about perspective. A world demoted in one category can rise in another, not by title but by what it may harbour. The dwarf planet with a frozen heart may, in fact, carry an ocean that ties it to some of the most promising habitats for life in the cosmos. And yet, not everyone is convinced. For every hopeful vision of hidden seas and dark ecologies, there are voices urging caution. Data, they argue, is sparse. Models may be misleading. Our imaginations may run too far ahead of the evidence. From here, we will take our seat on the skeptic's bench, to hear the counter-arguments, to weigh doubts against wonder, and to ask, is Pluto truly alive with secrets, or are we projecting stories onto ice and stone? Not everyone is ready to welcome Pluto into the club of hidden oceans. For all the wonder sparked by New Horizons and the models that followed, many scientists remain cautious, even skeptical. From their perspective, Pluto's secrets are still wrapped in too much uncertainty, and to leap too quickly into visions of life-bearing seas may be more wishful thinking than science. The first and most obvious concern is the lack of direct evidence. Unlike Enceladus or Europa, Pluto has not given us plumes of water to sample, or magnetic signatures that betray the presence of liquid beneath the ice. What we have are surface features, cracks, bulges, and smooth plains that could suggest internal activity. But geology is a tricky storyteller. A fracture on Pluto might hint at rising water, or it might be the scar of ancient impact. A smooth plain might mark slow-moving ice, or it might simply be the result of surface relaxation over time. Without direct probes or long-term monitoring, we are left to interpret still images, and interpretations can mislead. This leads to a second worry, the risk of pareidolia in data, the human tendency to see patterns where none exist. Just as we sometimes see faces in clouds or animals in rock formations, scientists may be at risk of projecting significance onto Pluto's landscapes. A heart-shaped plane becomes a symbol of vitality. A crack becomes a sign of liquid motion. But in reality, these features may have simpler explanations, rooted in physics and chance. As one skeptic put it, we may be turning Pluto into the world we want it to be, not the one-eyed island. Another point of caution lies in the energy budget. Pluto is small, its core cold compared to larger moons with powerful tidal heating. The amount of radioactive decay in its rocks may not be enough to keep an ocean liquid for billions of years. Over time, skeptics argue, any internal heat should have dissipated, freezing the ocean solid. What models suggest as a warm sea might in fact be nothing more than a relic once liquid, but now long gone, locked forever into ice. These voices of skepticism are not meant to dismiss Pluto, but to sharpen the conversation. Science grows not only from wonder but from doubt, and the most extraordinary claims require extraordinary evidence. By holding back enthusiasm, skeptics help ensure that when claims are made, they are tested rigorously, not just imagined into being. And yet, even on the skeptic's bench, there is room for curiosity. For every argument against Pluto's ocean, there remains the counterweight of possibility, that the cracks really do tell a deeper story, that heat and chemistry might linger longer than expected, that nature may be more resourceful than our models allow. Another line of skepticism points to the limits of our observations. New Horizons, remarkable as it was, only passed Pluto once. In a fleeting flyby that lasted mere hours, the spacecraft gave us stunning images and invaluable data, but only from one side of the planet, at a single moment in time. We have no continuous record of seasonal changes, no radar capable of peering beneath the crust, no seismic instruments to feel the tremors of a living interior. To build sweeping claims about hidden oceans from such limited information, skeptics argue, is like trying to understand Earth's climate from a single afternoon snapshot. Compounding this is the risk of confirmation bias within the scientific community. Pluto's demotion in 2006 left a cultural scar, not just among the public but even among researchers who had spent their careers studying it. To see Pluto regain significance as a member of the Ocean World's Club is tempting, almost redemptive. Skeptics caution that such emotional undercurrents can influence interpretation. When a cracked plane might mean either tectonic stress or liquid beneath, the allure of Pluto still alive can tip the scales unconsciously. They also raise questions about comparisons to other moons. Europa and Enceladus show evidence of active geology and, crucially, present-day plumes, features that can be tested and sampled. Titan's chemistry, though alien, is visible in its atmosphere and lakes. Pluto, by contrast, sits at 5 to 7 billion kilometers from the Sun, receiving a fraction of the light and heat. Its surface is colder, its mass smaller, its environment harsher. To assume that because Europa and Enceladus have oceans, Pluto must as well, is, in the skeptic's view, an overreach. Each world is unique, and analogies may obscure more than they reveal. And so, from this bench of caution, Pluto looks less like a promising candidate for life and more like a frozen relic. A fascinating geological body, yes, but one whose potential oceans may be locked in ice, whose heartbeat might have stilled long ago. Yet even here, balance persists. The skeptic's caution is not a rejection of possibility, but a demand for rigor. They remind us that science is strongest when it resists easy answers, when it holds space for both wonder and restraint. In this way, skepticism is not the end of the story, but a vital part of its telling. Skepticism, in the end, is not cynicism. It is the careful voice that asks, what do we really know? And in Pluto's case, the answer is not nearly enough. The cracks and bulges on its surface might speak of an ocean, or they might be scars of ancient impacts. The smooth plains may suggest slow glacial flows, or they may be the quiet settling of frozen nitrogen. Models of internal heat point in different directions. Some show an ocean preserved, others a solid core locked in silence. From this perspective, caution is wise. Extraordinary claims, oceans beneath ice, life in the dark demand extraordinary evidence. And until we send instruments capable of listening to Pluto's interior or sampling its chemistry directly, the truth will remain hidden behind layers of ice and uncertainty. Yet even on the skeptic's bench, there is room for wonder. For every reason to doubt, there lingers a reason to stay curious. The absence of plumes does not prove the absence of water. The silence of Pluto today does not erase the possibility of activity yesterday or tomorrow. History has shown us, time and again, that the solar system is more surprising than we expect. Worlds once dismissed as barren Mars, Europa, Enceladus have revealed stories of water, chemistry, and possibility. Perhaps Pluto, too, waits for its turn to surprise us. And perhaps all it takes is a patient ear missions not to impose answers, but to listen for whispers beneath the ice, to let the dwarf planet reveal what it has been keeping in the dark. If Pluto is keeping a secret, the only way to uncover it is to go closer. Telescopes across billions of kilometers can only hint, their images blurred by distance and time. A single flyby like New Horizons gave us a glimpse, but glimpses are not enough. To truly know whether an ocean stirs beneath the ice, or whether Pluto's silence hides chemistry worth listening to, we must linger. We must place instruments in orbit, on the surface, even beneath the crust itself. One vision is of an orbiter, circling Pluto for years instead of hours. By tracking its motion with exquisite precision, scientists could map tiny variations in gravity, the subtle tugs that betray a liquid ocean shifting inside. The orbiter's cameras could watch how frost changes with the seasons, while spectrometers would trace the faint signatures of methane, nitrogen, or even organic compounds drifting through Pluto's thin air. Unlike the hurried flyby, such a mission would let Pluto speak slowly, revealing its patterns over decades. But to hear its heartbeat more directly, explorers dream of a lander, anchored on the icy plain of Sputnik Planitia. Such a craft could lower seismic instruments into the ground, waiting for tremors. Every tiny quake, every vibration would echo through Pluto's crust, whispering of what lies below. A microphone of sorts, tuned not to sound, but to movement, letting us feel the planet's interior without ever seeing it. And then there are the boldest ideas of all, the cryobots. Machines designed to melt their way downward through kilometers of ice, carrying sensors as they descend. Slow, deliberate, persistent, like candles sinking through a frozen sea. If one could ever reach Pluto's hidden ocean, it might release floating probes into the dark waters, letting them drift and listen, searching for the faintest chemistry of life. The thought feels almost like science fiction, yet engineers sketch its outlines seriously, knowing that the hardest part of exploration has always been daring to imagine. Every one of these proposals, orbiter, lander, cryobot, is a kind of listening, not imposing noise, not demanding spectacle, but leaning close to hear what Pluto might already be whispering. After all, if there is a sea down there, or even a shadow of life, it does not shout. It waits in stillness, as it has for billions of years. Our task is to be patient enough and persistent enough to hear it. To listen across billions of kilometers, we must learn to read the faintest signals. Gravity, for example, becomes a language. An orbiter tracing Pluto's path would feel subtle, pulls tiny accelerations and decelerations as it passes over mountains, basins, or perhaps a pocket of liquid hidden deep inside. By mapping these shifts with patience, scientists could draw an invisible picture of Pluto's interior, a portrait painted not with light, but with motion. Seismology offers another form of hearing. On Earth, Seismometers capture the ripples of earthquakes. On Pluto, a lander could do the same with cracks or distant impacts. Each tremor would travel differently through ice, rock, or water. A quake that echoes like a bell might betray an ocean's hollow chamber, while a dull, muffled thud could confirm a solid, frozen heart. To lie quietly on Pluto's surface, recording its occasional sighs, would be like pressing an ear against the wall of a sleeping world. And then there is the power of light itself. Spectrometers, tuned to sniff out molecules, could analyze the faint glow of Pluto's hazy atmosphere or the frost that coats its plains. Every wavelength carries a fingerprint. A trace of ammonia could confirm an antifreeze in the ocean. A whiff of methane might point to active chemistry at work. If organic compounds drift upward, carried from surface to sky, they would reveal themselves in spectral lines, as delicate as ink strokes on a pale page. Together, these tools form a kind of orchestra of listening. Gravity provides the bass, seismology the steady percussion, spectroscopy the bright, searching notes. None can play the full melody alone, but when their data are woven together, they could let us hear Pluto's hidden song for the first time. What makes this dream so compelling is not just the promise of discovery, but the way it reframes exploration itself. Instead of conquering or claiming, we would be practicing patience, waiting, listening, allowing Pluto to reveal what it has been holding for billions of years. When we imagine these missions, it is easy to picture steel and circuitry, equations and checklists. But beneath all the engineering lies something softer, the desire to hold a conversation with a world that has been silent for eons. Pluto does not send signals to us willingly. It only responds when we learn to listen with enough care. The orbiter that measures its pull, the lander that feels its tremors, the spectrometer that reads its chemistry, each is a kind of question. And if we are patient, Pluto may yet answer. There is a quiet beauty in the thought of a machine resting on Sputnik Planitia, its antenna raised, not to shout, but to wait. The thin winds would sweep frost across its body. Charon would hang unmoving in the sky, like a watchful lantern. Day after day, year after year, the lander would do little more than record silences until, perhaps, a shiver in the ice revealed something moving deep below. A single trace in its data would change our understanding forever. Cryobots stretch the imagination further. One can envision a probe descending inch by inch through the ice, leaving behind a thread of sensors like breadcrumbs. The descent might take years, perhaps decades, yet every meter down would feel like peeling back a secret page of Pluto's history. If it ever reached the ocean, and if it released small swimmers into the abyss, their sensors would not see light but hear chemistry, pH, salinity, organic compounds drifting like dust. It is not a voyage of conquest, but of humility, a willingness to meet life on its own terms if life is there to be met. The skeptics remind us that all of this may lead only to silence, to the confirmation that Pluto is solid and frozen, a relic rather than a cradle. But exploration has never been about guarantees. It has always been about reaching toward the unknown, knowing that even a negative answer enriches our view of the cosmos. To send a listener to Pluto would be to honor both science and imagination, the discipline to demand proof, and the courage to believe the proof may be worth finding. And so the call for listening missions grows, not with urgency but with persistence. Like a soft knock at a closed door, it is steady, patient, insistent. One day, whether through an orbiter, a lander, or something bolder, we may place our ear against Pluto's frozen heart and hear what it has been whispering all along. If Pluto does shelter life, even the simplest forms drifting unseen in its hidden ocean, then a question arises that is larger than science. What right do we have to interfere? Discovery is thrilling, but it carries weight. For every spacecraft we send outward, for every probe that drills or lands, there is a chance, however small, that we might disturb what has endured undisturbed for billions of years. This is why space agencies speak of planetary protection. The idea is simple, yet profound. we must not contaminate other worlds with life from our own. Microbes cling stubbornly to spacecraft, hiding in screws and seals, surviving radiation and vacuum. If we were careless, a bacterial hitchhiker from Earth could find its way into Pluto's ice, leaving behind a false signal that misleads future explorers, or worse, overwhelming whatever fragile native life might already exist. But protection is not just about avoiding contamination outward. It is also about guarding Earth from what we might bring back. Though the odds are slim, if a probe ever returned samples from Pluto's ocean, we would have to ensure that no alien chemistry could harm our biosphere. The barriers would need to be as careful as any quarantine, not out of fear, but out of respect for both worlds. Beneath these protocols lies something deeper, a philosophy of humility. For centuries, humanity has treated new lands as places to claim, to extract, to reshape. But the cosmos asks us to move more gently. If Pluto holds life, even microbial, it would not be ours to possess. It would be a story running parallel to our own, precious precisely because it evolved in solitude, untouched by us. And so, when we imagine the cryobots melting downward, or orbiters tracing Pluto's breath, we must also imagine the restraint required to explore without harming, to learn without leaving scars, to recognize that the act of listening, of waiting, may itself be the most ethical form of discovery. The tension between curiosity and caution is not new. Every era of exploration has wrestled with it. When Europeans first crossed oceans on Earth, they carried with them plants, animals, and microbes that transformed entire continents. Some of those encounters brought knowledge and exchange, others brought devastation. Space, though unimaginably vast, asks us to reflect on those histories before we repeat them on a cosmic scale. Within the scientific community, the debate often falls between two poles. On one side are those who argue that we must push forward, that the search for life is too important to wait, too urgent to be bound by fear of contamination. After all, they note, cosmic impacts have been trading material between worlds for billions of years. Microbes from Earth may already have reached Mars or beyond, hitching rides on meteorites. If life on Pluto exists, it may have been exposed to foreign chemistry long before we arrived. Why, then, should we hesitate? On the other side stand the guardians of restraint. They argue that what makes Pluto, or any ocean world, valuable is precisely its untouched nature. If life is discovered, even a single cell, it would represent an independent origin, proof that life is not unique to Earth. To contaminate such a discovery with Earth, microbes would not only risk destroying it, but also risk confusing us, blurring the line between native and introduced. A false signal could haunt generations of research, leaving us forever unsure what was truly Pluto's and what was ours. The question grows sharper when we imagine the technologies involved. A cryobot tunneling through ice cannot be sterilized completely. Heat, drills, and sensors will inevitably carry remnants of Earth. Does that mean such missions should be forbidden? Or should we weigh the risk against the potential gain, to the chance to glimpse life where none was expected, to answer questions older than history itself? Perhaps there is no perfect answer, only a balance. Exploration without reverence becomes exploitation. Reverence without exploration becomes stagnation. Between them lies a narrow path, careful, deliberate, with safeguards at every step. To walk that path is to acknowledge that our hunger for knowledge must be tempered by responsibility. And responsibility, in this context, is not a burden but a kind of grace. To ask whether we should touch, not only whether we can, is a sign that humanity is maturing in how it sees the cosmos. Pluto's secrets may tempt us, but perhaps the first lesson it teaches is patience. To say do no harm is not to say do nothing. It is to carry our curiosity with care, to understand that knowledge gained recklessly can become knowledge lost. If Pluto holds life, it is fragile, not in the sense of weakness, but in its uniqueness. A single cell, evolved apart from Earth, would be a treasure beyond measure. To disturb it without thought would be to silence a voice that has spoken, alone, for billions of years. And yet, protection is not the opposite of exploration. It is its companion. The very act of pausing, of asking whether we should, gives weight to the moment when we finally do. If one day a probe melts into Pluto's crust, or listens for the pulse of its ocean, the meaning will be deeper, because we took the time to question ourselves first. Discovery tempered by humility becomes more than science, it becomes wisdom. There is also a lesson for us, here on Earth. The way we approach Pluto reflects how we see our own planet. If we can learn to explore gently in places so far away, perhaps we can learn to live more gently at home, too, recognizing that fragility is not weakness, but a form of beauty worth preserving. So we sit with the paradox. We long to know, yet we must be careful not to harm. The silence of Pluto's ocean, if it exists, reminds us that waiting can be an act of respect, that restraint can be a form of wonder. In the end, exploration is not only about reaching outward, but also about shaping who we are as listeners, caretakers, and companions in a universe that may hold more lives than just our own. If beneath Pluto's ice there drifts even a trace of life, a single strand of microbial existence, sealed away in darkness, then the question before us is no longer only scientific. It becomes philosophical, almost spiritual. What would it mean for humanity to realize that life has blossomed not once, but twice, in a single solar system? For centuries we carried the weight of loneliness. Earth seemed singular, the rare oasis in a vast desert of stars. Our myths reflected this solitude, and even our science hesitated before the possibility of neighbours. Yet if Pluto, cold and distant, harbours life beneath its crust, the silence of the universe shifts in tone. It suggests that life is not the exception, but the rule, that wherever liquid water lingers, however faintly warmed, nature has a way of filling it with persistence. This would change the way we measure what is habitable. We often think of sunlight as the essential ingredient, photosynthesis feeding forests, warmth feeding rivers. But Pluto would whisper another truth, that the universe may care less about light than about water. Oceans, even buried ones, become more important than skies. Chemistry, more than sunshine, becomes the true engine of survival. There is something humbling in this perspective. It would mean that the cosmos is not stingy with life, but generous. That beneath the frozen crusts of Europa, Enceladus, Titan, and perhaps Pluto, there may already be multiple examples of biology thriving unseen. Life, then, would not be a solitary flame flickering against the night, but a constellation of sparks scattered wherever conditions allow. And yet, the thought does not diminish Earth. If anything, it deepens our appreciation. For even if microbes exist in Pluto's dark sea, they have endured in silence for billions of years. Here, on Earth, life reached upward, building complexity, creating voices and stories. We may not be alone, but we may be the first to look back into the dark and realize we are part of something larger. The possibility is staggering, and it reshapes how we see ourselves. To discover life on Pluto would not simply answer a question, it would expand the horizon of every other question we ask. To imagine life on Pluto is to imagine a profound shift in perspective. For so long, humanity has lived as though we were the center of the cosmic stage. Even after Copernicus and Galileo displaced Earth from the middle of the universe, we still held fast to the belief that we were unique in our biology, a singular oasis in an ocean of emptiness. But if Pluto harbours even the most modest form of life, that story begins to dissolve. The solar system itself would contain at least two origins, two sparks struck from different flints. And if two, why not 10? Why not 1,000? Scattered across galaxies. Suddenly, life is not an improbable miracle, but a natural unfolding the universe's habit, rather than its accident. Some philosophers of science have called this possibility the principle of cosmic mediocrity, that we should not assume Earth is special, but rather typical. It is a humbling thought, one that pulls against centuries of anthropocentric pride. If Pluto, cold, dim, and far, has managed to shelter biology, then life does not need paradise to begin. It only needs chemistry, water, and time. This flips the narrative we so often carry. We have asked, what rare set of circumstances allowed Earth to bloom? But perhaps the better question is, how many places are blooming still? Pluto, by its very existence, would whisper that the cosmos is fertile in ways we never dared to imagine. And such knowledge would not only expand our horizons, it would reshape our sense of kinship. We are used to thinking of life as fragile, as something that exists only in a thin shell of air around a small blue world. But a discovery on Pluto would remind us that life is also robust, that it can thrive without sunlight, without forests or oceans under the sky, that it can persist in silence, carried forward not by spectacle but by endurance. The emotional weight of such a realization is difficult to capture. It would mean that Earth is not an island but part of an archipelago of life. It would mean that when we gaze into the dark, we are not staring into a void but into a sea of potential neighbors, not human, not familiar, but alive nonetheless. And in that recognition lies both humility and hope. Humility because we are no longer the center, hope because we are no longer alone. If somewhere in the dark ocean of Pluto a living cell drifts, then the meaning of that discovery would echo far beyond science. It would remind us that life is not fragile chance but resilient pattern, not confined to Earth's gardens but seeded wherever water and chemistry conspire. The shift would not come with fanfare. Microbes on Pluto would not build cities or send signals across space. They would remain silent, unseen, persisting in a rhythm older than humanity. And yet, their very existence would change everything. It would tell us that we are not singular, that the thread of biology has been woven more than once. In that simple truth lies a revolution. The universe itself is not indifferent but generative. Such a revelation would also soften the boundaries we draw around ourselves. For centuries, we have spoken of us and the cosmos as though they were separate. But if life has blossomed twice in one solar system, then we are kin to the cosmos in a deeper way. Pluto's ocean, if alive, would not be alien so much as distant family, different in form but sharing the same basic spark that animates us. And perhaps the most humbling lesson is this: life does not require grandeur. It does not need sunlight, forests, or open skies. It can endure quietly, in hidden seas, waiting out the eons. What matters is not spectacle but persistence. In this sense, life on Pluto would mirror life within us, a reminder that survival itself is a kind of miracle, repeated across scales and worlds. To stand beneath the night sky and think of such a possibility is to feel both small and vast at once. Small, because our story is not unique. Vast, because our story is part of something far larger than we imagined. If we are not alone here, then we are not alone anywhere. The cosmos is not empty. It is alive with whispers, waiting for ears patient enough to listen. At the farthest reaches of the sun's domain, Pluto drifts in silence. To the naked eye, it is only a faint star among millions. But thanks to the spacecraft that brushed past it, we know its face now, the plains of nitrogen ice, the canyons etched in shadow, and above all, the great pale heart of Sputnik Planitia. From across the void, that heart gleams like a lantern. Fragile, cold yet unmistakable, a small light at the edge of our cosmic map. There is something almost human in the way we cling to that image. We call it a heart because it looks like one, but also because it feels like one, a sign of vitality in a place we once thought lifeless. It is easy to imagine the frozen plains glowing faintly, as though Pluto itself were keeping vigil, a quiet lamp burning in the deep. For centuries, the frontier of the solar system was little more than a line on paper, an empty margin beyond Neptune. Now, it has a face, a symbol, even a story. When we picture Pluto, We no longer see just a dot on a star chart. We see the heart-shaped plane, the blue haze of its atmosphere, the companionship of Charon hanging nearby. We see a world that, despite its exile from planethood, carries its mystery with quiet dignity. Pluto's heart has become more than geography. It has become a metaphor, a reminder that even in the coldest and loneliest corners, there can still be light. Not the blazing fire of a sun, but the softer glow of persistence, an invitation, patient and enduring, to return someday. When we think of lamps, we think of warmth, of guidance, something that glows softly in the dark, not to dazzle, but to remind us we are not lost. Pluto, in its way, has become such a lamp. Its icy heart reflects what little sunlight reaches it, scattering it back across space as though to say, "I am here, do not forget me." From Earth, that light is faint beyond measure, but in the imagination, it becomes brighter than its physics allow. It becomes a symbol of endurance at the edge of night, where a world too small to clear its orbit, too distant to keep warmth, still holds mysteries that could reshape our place in the cosmos. In its pale glow we see both fragility and resilience, a paradox that draws us closer in thought if not in distance. There is comfort in knowing that Pluto waits, unhurried, untouched by the passage of our centuries. Long after empires fall and cities crumble, Pluto will still orbit the sun, heart intact, lamp steady. Its light is not one we see with our eyes, but one we feel with our curiosity, the pull to keep asking, to keep listening, to keep searching in places we once dismissed as empty. Perhaps this is why the image of Pluto lingers so strongly in us, not only because of science but because of story. We love the idea of an outcast world, demoted yet dignified, carrying its heart across the frozen dark. We love the idea that even the smallest, most overlooked places can shine. In that way, Pluto becomes less a planet or a dwarf planet and more a character, a companion at the edge of our shared journey. And as with any lamp, its value is not in blazing brilliance, but in quiet presence, in reminding us that the frontier is never fully closed, that there are always lights yet to be found, waiting at the margins. Perhaps that is Pluto's greatest gift to us, not answers, not certainty, but a light we can follow in the dark. It shines not with fire, but with suggestion, not with brilliance, but with patience. It does not demand our gaze, yet once seen, it is impossible to forget. When we look at Pluto, we are reminded that the universe is not composed only of giants and blazing stars. It is also made of small worlds, quiet companions, places that whisper instead of shout. The heart on Pluto's surface is not proof of life, nor a promise of discovery. It is something gentler, an emblem of endurance at the farthest edge of sunlight, a lamp at the threshold between what we know and what we still long to find. In that way, Pluto invites us into a different kind of relationship with the cosmos, not one of conquest, but of kinship, not one of dominance, but of listening. Its pale glow reminds us that mystery itself can be enough, that to wonder is already to be illuminated. So let us leave Pluto where it belongs, drifting in the quiet, cold, lamp burning softly. We do not need to hold it, or claim it, or solve it all at once. We need only to know that it is there, a small light at the edge of our night sky, waiting. And in that waiting, in that gentle persistence, Pluto becomes a beacon not just for science, but for imagination, a reminder that even in the deepest dark, something shines. And now, with Pluto's faint lamp still glowing in our thoughts, we can let the story settle. The heart of ice, the possibility of oceans, the long companionship of Charon, all of it drifts slowly to the background, like constellations fading behind closed eyes. It is late, and the universe will wait. You don't need to solve its mysteries tonight. They will still be there tomorrow, steady as ever, circling in silence. For now, you can simply rest in the comfort of knowing that even at the farthest edge of the sun's light, something endures. A world too small to dominate, too distant to warm, yet luminous enough to remind us that wonder has no boundaries. Take a slow breath. Feel your body soften against the bed, the pillow, the quiet around you. Imagine the darkness above Pluto's plains crisp, star-filled, untouched by noise. Let that silence flow into you, steadying your heartbeat, loosening your thoughts. If you've been awake longer than you meant to, that's all right. Even sleepless hours can hold beauty, like a secret shared with the night. And if sleep comes to you now, let it carry you gently, as though you are drifting across space yourself, rocked by invisible tides. Thank you for joining this quiet voyage. It is a small joy to know that scattered across Earth, from busy cities to quiet countryside, from early mornings to late nights, there are listeners sharing this same moment of stillness. Together, we make a constellation of our own, tiny lamps glowing under the same sky. May your dreams tonight be soft and unhurried, touched with the calm of distant worlds. Rest well, traveller, and let the heart of Pluto keep its watch while you sleep.